We're given that z to the n plus 1 over z to the n is equal to 2 cos n theta. We want to show this expression just here. If we take n equal to 1, we have z plus 1 over z would be 2 cos theta. We want a cos to the power 6 theta. If I do 2 cos theta to the power 6, that's going to be equal to z plus 1 over z to the power 6. And we can expand that out using the binomial theorem. If we use Pascal's triangle, the line we want is 1, 6, 15, 20, 15, 6, 1. So, 64 cos to the 6 theta is going to be z to the 6. Then we're going to have 6 z to the 5 1 over z, which will simplify to z to the 4. Then we'll have 15 z to the 4 1 over z squared. That will simplify to z squared. Then the z's will cancel in the middle term. And then continuing on with that expansion in the same way, we'll get 15z to the negative 2 plus 6z to the negative 4 plus z to the negative 6. Now, it's all about grouping from this point. We want to put these ones together, and we'll want to put these ones together, and we'll want to put these ones together. So we have 64 cos to the 6 theta is z to the 6 plus 1 over z to the 6. And then we'll have 6 z to the 4 plus 1 over z to the 4. And then 15 z squared plus 1 over z squared. And then the 20 all on its own out here. Now, if we come back and look at this, z to the 6 plus 1 over z to the 6 is going to be 2 cos 6 theta. Z to the 4 plus 1 over z to the 4 will be 2 cos 4 theta, and so on. So we can make this first one into 2 cos, so 64 cos to the 6 theta is 2 cos 6 theta. Then we're going to have 6 times 2 cos 4 theta. Then 15 times 2 cos 2 theta. And then we've got 20. And so dividing everything by 2 gets us 32 cos the 6 theta is equal to cos 6 theta plus 6 cos 4 theta plus 15 cos 2 theta plus 10, because we had divided by 2, didn't we? And that is the expression that we were after. So that is part A. Now, how does the question continue from there? So figure 1 shows a solid paperweight with a flat base. Figure 2 shows the curve with equation y equals h cos cubed x over 4, where h is a positive constant, x is in radians. The region R, shown shaded in figure 2, is bounded by the curve, the line with equation x equals negative 4, the line with equation x equals 4, and the x-axis. We can see all of that in the diagram. The paperweight is modelled by the solid of revolution form when R is rotated 180 degrees about the x-axis. Given that the maximum height of the paperweight is 2, write down the value of h. Well, we know that cos has a maximum value of 1, and that tells us that h is equal to 2. in part C, using algebraic integration and the result from part A, determine in cubic centimetres the volume of the paperweight according to the model, giving your answer to 2 decimal places. Well, we know that a volume of revolution is pi times the integral of y squared dx. That's when you go all the way around. So here we're going to have a half pi because we're only going half of the way around. And therefore, our volume is going to be half pi times the integral from -4 to 4 of 2 cos cubed x over 4, using the value of h there as being 2, squared dx. So we want to evaluate that integral. So that is going to be a half pi times the integral from -4 to 4 of 4 cos to the power 6 x over 4 dx. And then we can make use of this. Notice here that we only have 4 of these, and that here we have 32 of them. So we have 1/2 pi times the integral from -4 to 4 of 1/8 of. So the first one is cos 6 theta. Well, that's going to be 6 times x over 4 in this situation. So that ends up being cos 3x over 2. Then same sort of thing with the next one. It's cos 4 theta. And remember, we're using cos x over 4. So that one's going to just be 6 cos x. And then the next one will be 15 cos x over 2. And then we have the 10. So all of that being integrated with respect to x. So we can slide that 8th out of there and have a pi by 16 out the front. And then we're integrating from -4 to 4 cos 3x over 2 plus 6 cos x plus 15 cos x on 2, add 10. So that's pi on 16. So cos integrates to sine, so we're going to get sine 3x over 2 divided by 3 over 2, so that ends up being 2 over 3. And then we're going to have 6 sine x. That will be 30 sine x on 2 plus 10x to be evaluated from -4 up to 4. Okay, so using the top limit, we get 2 sine 6 over 3 plus 6 sine 4 plus 30 sine 2 plus 40. And then with the bottom limit, we get 2 sine -6 over 3 plus 6 sine -4 plus 30 sine -2, take away 40. And of course, you could work that out at that point with the calculator, but we can simplify it knowing that sine is an odd function. That means that the sine of -6 here is the negative of sine of 6. So with that negative, it becomes a positive. And so we're actually going to get 4 sine 6 over 3. And then in the same way, we'll get 12 sine 4. And then in the same way, we're going to get 60 sine 2s. And we'll get an 80 because of the 40 take away -40, just like that. And so we can now put all of that in the calculator. And we'll get 24.56 cubic centimeters to the 2 decimal places required. The final part of the question, we go over and look at the final part. It says state the limitation of the model. And there's various things you can put down there. It's modeled as a smooth paperweight. What if it isn't? We've got accuracy of measurements taken. How good is the model? So the equation used. There's a whole host of things that you could put down there.